far that what we have seen so far is that in RL there is an agent. We need to let it understand how to behave in a certain environment. There are states, actions. There can be the policy. There can be Q value. There can be value functions and so on. And then we see that formally when we come up to define, decide, or model an environment, it's essentially come up with a MDP, Markov decision process. So suppose that now let us come up with an example of such a grid word, such an example, such a environment. So now this is an environment, very simple environment for you. I assume that we need to slightly camera. Which one is the camera? Okay. Right. Zoom minus. We do not require this much zoom. Okay, this zoom is okay. And yes, this side, no, this side. Fine. So this is a grid word in front of you. This is an environment, simple, very simple environment. And even if you want such a small environment, you need to code it properly in GYM, GYM, and it's going to somehow let you, play with such an environment. Okay. So now, what is the game? Now the game is that these are the two places from where you can get yourself considered as win. But you may be over here, 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 you may be over here. So it may be that you may be at different places. You may be at different places. From here, you need to see that how can I exit from this place? So these are actually the two exits by which you can go out of a cinema hall, and remaining are different seats where you can assume that you are actually seated. So let us so the question will be that given such an environment, if you are an agent, you need to let me know that if I am here, how can I move as fast as possible and lead or maybe reach to a terminal state. This works fine over here. Now, states 2D location. Very simple. There's a 2D grid, so you are having two location x comma y. Hello, can you listen?
Yes, sir.
Okay. So actions are left, right, top, bottom, because at any location you can go this, and this. Rewards can be +1 and -1. So here reward is not going to be anytime +1 because we wanted to get you out as fast as possible. So if you are taking one step, that is -1. So if you take more and more steps, your rewards need to be decremented. So we require a way by which minimum amount of reward, so which essentially means that this is just a punishment. You need to take as less as possible steps. What's your objective? Our objective is that starting from any random location and reach to a terminal state in the best number of steps as fast as possible. All right. Sorry, need to wait for a minute. I'm sorry. Oh, sorry. That was some urgent call. Right. So Gitanjali, can you listen? Yes?
Yes, sir.
Okay. Now, so we understood this all things what we need to do in this 2D world, which can actually be seen as an MDP, which is having 5 those things. We need to come up with a policy. So if I give you an MDP, what you have to give it to me? You need to give me a policy. The solution of an MDP is policy. You understand that if you give your politician 5 years or so on, they used to give you a policy, that 5-year policy, 10-year policy, Panchvarshi yojanas and so on. So they need to come up with a policy by which they can extract maximum DCFR. That's the thing. If you give me an MDP, the solution of an MDP is to provide you a policy which can an optimal, and not any policy, it has to be an optimal policy which is going to extract the maximum DCFRs as possible. Now, how can I visualize a policy in such a case, in such an environment? Just look it, and then I will ask with someone. This is a random policy, that is random policy A, pi 1. This is another policy B, maybe pi 2. And these are actually the visualizations of your policy. Let me ask maybe Prashant. Can you listen, Prashant? No. Sujit. Sujit, can you listen?
Yes, sir.
Sujit, so what do you see? This is a random policy. What do you understand with this such a type of random policy?
I can say that at any place.
आपकी आवाज बहुत कम आ रही, थोड़ा आप पास आकर के बोलें.
So at any place, I can move to any direction.
Any direction, right?
Yeah.
So from here, it is telling that in this direction, that with the equal probability you are moving everywhere. Now, what do you think
Yes.
about this policy?
So in this one, so we have already fixed. At some place, I can move only in one direction. In some place, we can move in both direction. In some place, 3 directions. So we have given priority to.
Right. Priority to certain direction. This is one
Yeah.
thing. If I say this is better or this is better, what is your thought?
Second one is better. Pi 2 will
Second
be-
one is better. First thing, that this is not a random policy. This is a random policy because here there are certain priorities. Now, how can you get such priorities? That is policy which is not random. Then how can you say, and now how can you say that this is better? Yes, Sujit, how can you say that this is better? Suppose that, Sujit, you are at 5th location.
Yes, sir.
How you need to go? Do you want to go to this guy, T2 or T1?
T1.
T1, that's what it's saying, right?
Yes, sir.
Similarly, you can think about maybe at 9. So at 9, it is saying either you go in this direction, then here, this direction, then here, this direction, then this direction. That is why it is saying that it is equally probable in 3, but don't go in this direction.
Yes.
Yes.
Yes, sir.
Yes. So if you all understand, please raise your hand. Both of these things. Please raise your hand. Both of these things. Do you understood? ठीक है, समझ गए. चलिए. Somebody has it. Okay. Priyanshu raised a hand. Priyanshu, you asked question. Yes, Priyanshu. Oh, no, sorry. Priyanshu raised the hand because I have said. Sorry. Policy. So now what's the philosophy of such a policy? That for immediate neighbors to the terminal states, if you are at a location which is just adjacent to some terminal, directly go in that direction. Else, at any other location, try to find out that how can you reach to the immediate next location. So basically the solution of an MDP is that optimal policy. You need to give me an optimal policy, which is essentially that you need to understand how to plan. So pi-astic, that's an optimal policy. It actually says that doesn't matter. You are at whatever state at time t. I'm going to tell you what is the best action AT you need to take in order to maximize your DCFRs. So you are standing at an state ST. You can see it over here. I need to go this direction. It is telling you that out of all possible actions, if you are at a state ST, pi is going to tell that which action that you need to take, and pi-astic will tell you that if you take this action, this is going to maximize your DCFRs. So there are pi 1, pi 2, pi 3, pi and so on, huge amount of pi's that you can have. Infinite amount of pi's can be there. We need to develop an algorithm by which systematically, probably we can start from some random policy, because you need to initialize something policy with some random thing. Once I take that random policy, I need a way by which I keep on modifying my pi in such a way so that I keep on getting better and better. And if I ensure that at every step my pi is somehow getting better, then at some point of time you will reach to a pi-astic. Right, how many students? So how many of you are crediting the course? Creditors, please raise your hand. 5. Very less. So you see that, I mean, in between it may happen that our creditors may get less because they know that the course is very heavy and initially they are interested. Auditors will anyways go out. Even when the creditors are not able to contribute, then it will be difficult. But yes, your point is that if you are doing the course, do it properly, because it's an essential thing, and next at least 1 or 2 years are going to be dedicated to such type of frameworks. Now understand. So when I say maximize the discounted cumulative future rewards, when I say that DCFRs you need to maximize, we are talking stochastically. What does that mean? It means that so you take a decision, you move, then you take a decision, then you move, and keep on doing, and do it for huge amount of time. In fact, then your episode got finished, then you play another episode, then you play another episode, then you play another episode. And for all these episodes, whatever the DCFR that you are going to get, we need to let my pi learn in such a way so that the expected value of such DCFR needs to be, the expected value of my DCFR need to be maximized. It's not a single value that you can maximize because it's a stochastic process. If there is a stochastic process, we always talk about something which is the expectation of something. You're not going to get a single value. For this episode, you will get this, for this something else, for this something else. Given a fixed, even for a given fixed policy. So use your pen and paper. Pi-astic. What is my pi-astic? Pi-astic क्या है? You write arg max over all pi's. There are huge amount of pi's. Out of all the pi's, We need to find out that pi for which this term is going to be maximized. Clear? Simple. So overall pi's, we are maximizing what? We are maximizing this term. What is this term? Expected value, later we will see. What is this? This is GCFR, given pi. You choose a pi, and for that pi, you play a trajectory. You find out its GCFR. Then you take the same pi again, play another trajectory, get the DCFR, and do it for a good amount of time. Take the expected average value. Then that pi done, take another pi. Have multiple episodes. Have an average DCFR. Then you take third pi, then you take fourth pi, then you take fifth pi. So for all the pi's that you can have, play it for a good amount of time, find out what is the expected discounted future reward that you can get from that pi. How we have written that for a given pi, what is the expected reward? And then you do it for all the pi's and see that which pi is maximizing this term. By the way, your S0 or the initial state is going to be coming from a probability distribution of your initial states. Every MDP is actually have PS0. PS0 is nothing but a probability distribution. 80 is going to be coming from your pi. ST plus 1 is going to be coming from next state, transition probability of your MDP. Any question? कोई question है किसी को? No question.
Sir, I have a question.
हाँ पूछिए.
Sir, so for a given pi, do we like accumulate these expected values? Yeah, for every episode we start from the new.
So I understood. So for every pi, maybe pi 1, first you take pi 1. Episode 1, episode 2, episode 3, 4, 5. Then you take pi 2. All episodes. Some good amount of episodes, because you cannot get all episodes. There are infinite amount of episodes. You cannot get all episodes. Then you take pi 3. Take huge amount of episodes, then you take pi 4, then you take huge amount of episodes, and so on, and do it for all possible pi's. So if I give you the theoretical definition, because this is actually a definition of your pi asterisk. Theoretical definition says that for all pi's, how many pi's are there, Dipali? How many pi's are there, Dipali?
A lot of them.
Yeah, so they're infinite, by the way. Yes, no?
Yes.
So there are infinite pi's. Okay, if I give you one pi, how many episodes you can play?
We can decide that.
No, not decide. You just tell me that how many you can play. Essentially, how many are there?
20.
Infinite. Yeah, there are again infinite, right? Yes, Dipali? No. Komal, can you listen? Komal has written something. Can you listen to me?
Yes, sir.
Okay.
Yes, sir.
Yes. So infinite pi's, for each of them, infinite episodes, you take one pi, all possible infinite episodes, find out what is the expected DCFR. That is the expected DCFR of true. That's not even the approximated sampling that we are doing. That's the exact average DCFR that you can get from pi 1. Then do it for pi 2, then do it for pi 3, pi 4, pi 5. Essentially, infinite pi's. Out of one, whichever is minimizing it, that is your pi stick. Dipali, do you understood?
Yes, sir. So basically for each pi we start new, but for the given pi we accumulate. Is that right?
Given pi, so if you have infinite things, then you try it one by one, right? I'm not talking about the algorithm, because this thing cannot be realized. That's the actual definition of your pi stick. How we do it, that's a separate thing. But if you have infinite things, then you do it one by one. First pi, second pi, third pi, fourth pi, fifth pi. For each and every pi,
Mhm.
play all the possible trajectories. Find out the max,
Okay.
find out the average value. And then out of all the pi's, whichever is having the maxima, that is the one which will be your pi stick.
Yeah, but sir, is it theoretically you can do, but in practical scenario?
नहीं प्रैक्टिकल में तो बाद में आएंगे ना, पहले तो थियोरेटिकली समझ लो कि ये है, ये निकालना है, कैसे निकालेंगे, आई विल टेल यू. Okay. And the other thing is that most of the time in such a scenario, we do random sampling. We need someone who can tell you that this pi is good or this pi. How can we optimize over pi? That is one thing. And there we need second one, that given a pi, it will sample certain number of trajectories and do this averaging. So we do not play infinite trajectories. Instead, we play 10, 15, 20 or something and take the average of that. That is that if you have a stochastic process, you sample from it and take the average. And that is why you are using this expectation. Yes. Okay, Diwali.
Yes, sir.
Okay. So theoretically, this is the definition. So there are few attributes associated to such a policy. So if I give you a policy, few attributes are there. What is policy? Always remember, this is your policy. Policy is given ST, what is AT? This can be a stochastic policy, which is that instead of giving you some specific action, it will give you a distribution over all the policy or over all the actions, or it can directly give you maybe A1 or A5 or some specific fixed action. So that is a deterministic policy, or it can be a stochastic policy. Do you all understand the difference between deterministic and stochastic policy? Yes, no, raise your hand. Yeah, it's very important. You all need to understand. Sujit says yes. Okay. Okay, fine. Komal, you are not saying yes. Komal Kumar. Yes, Komal भी कह रहे बहुत जल्दी बदल रहा है. Okay. Now, given a policy, if I give you a policy, you can give me two things, the value function and the Q function. What's the value function? Value function pi can actually be how good a given state is. If I'm in a state ST, how good my state is. How can I know that how good my state is? If agent just follow pi, if agent keep on following just given pi, how much DCFR is expected is the value that the state S for a given policy pi. So you are at a state, whatever. I wanted to know how good a state is. I am saying that Vs. A state is as good as maybe Vs. Now, what is the meaning of this? That you are at state S, and now you keep on moving. And then you see that, oh, how much amount of DCFR I have got. That is the how good this state is. But you don't do it for one time, you do it for good amount of time. So this is for a pi. that if I give you a state and a pi, what is the maximum that you can achieve? So you, from that state, you apply pi multiple times, play a huge amount of episodes, and then you say that how much amount of return I can get. That is the value of any state. What is the Q value? That's the quality of an action. What does that mean? This means that with respect to a given policy, both of these things are coming after you choose your policy. Once you choose your policy, now I say that I wanted to know, at some point of time, I asked Sujit that I have shown pi 1 and pi 2, which one is better? He say pi 2 is better. Here, we are trying to define terminology by which we can probably understand that given two policies, which one is better? Because you now have a comparator which can compare two policy. When you can compare two policies, then you can even tell or understand that whether your policy is improving or not. So your Q value function will say how good is a state action pair. At this state, if I take this action, how good it is? Value function is saying at this state, given pi, understand, let me write it down. V pi s, other thing is Q pi sa. V pi s is saying that how good. So given this pi, how good my state s is. Quality function is saying, Q function is saying, given a pi, how good action A is with respect to this state. So if I take this action at this state, how much I can achieve. Okay. Now, definition of value function V pi s is nothing but, I have said it multiple times, let us see it. Mathematically, it's very simple. What it is saying, please write it down. V pi s is equal to the expected value of the DCFRs given that state is s and I am following pi. कैसे पढ़ेंगे इसको? मैंने आपको बताया इसको पढ़ते कैसे हैं. How can we read it? We are reading that the expected value of DCFRs, provided that my state st or my initial state is s. Why? Because we are talking about vs, v pi s. So my initial state is s and I'm following pi. Okay. You must have seen that k equal to 0 to infinity pi k r t plus k. Any question to this? You just keep on placing it things over here, you are going to get r. K will be 0, so it will be rt. So what it's going to be, it is going to be rt plus gamma rt plus gamma square. So it will be t plus 1, then gamma square rt plus 2 and so on. Okay, that's the discounted reward. Any question? किसी को कोई क्वेश्चन हो पूछ ले. Please explain again why. कोमल क्वेश्चन पूछो. Your mic is not working. No. You can write in chat. What do you want to know? ये तो straight है. You can ask your question. अगर आपका mic नहीं चल रहा तो आप लिखें कि my mic is not working. Infinite. Komal, please explain. Why? RT. अच्छा RT. Why RT? Because भाई आप See here, you are at state ST. आप ST स्टेट पे हो, ST से कहां जाओगे? ST+1 पे जाओगे, ST+2 पे जाओगे, कहीं चलता है कहीं नहीं, and keep on going like this. So that is why it is first RT. T is, ST is actually for the time. So when your time is starting, so there is another, these are like representations which actually being used. So if I take T equal to T is not starting from 0, T is starting from T. That's why you can see that T, then T+1 plus T+2, T+3, T+4, and so on. In upcoming next definition, they will assume T equal to 0. So now you can change it. If it is T equal to 0, then what's going to be? It's going to be RT. Then it will be R power T. And here it will be R simple T. Komal, understood? No. Don't worry. ये naming convention है. It's anyways going to be coming in the upcoming slides. वैसे इस पर ज़्यादा समय नहीं बिताना चाहिए. You just need to understand this is global time. Right now you are at here. T. I am saying that is your T. If you assume your T is starting from 0, which is over here, then that's right now T. If somebody will say, hey, T is starting from equal 0 from here. If T is from here, then there is no K. Your T itself is increasing. Why you want a K? You want a K because your T was 0 over here. Right now you are here, then your K is increasing 1 by 1, and that's why you are saying that T plus K and so on. When I say that T itself is over here, T itself is 0 over here, then T+1, then T+2, then T+3, and so on. So all these definitions are equivalent. ठीक है? Anyways, वो आगे फिर आएगा, मैं शो कर दूंगा फिर से. Q value function. लिखो इसको. Q value function, you are going to have states S1, S2, S3, S4. Maybe 3 states, 2 actions. How many state action pairs you are going to get? 3. And these are those. What are the things that you are going to have? You may have, you just choose some S2. Just for this state, I'm just choosing one state, you can choose any one. For this state, S2, you may have V pi S2. Let us ask someone. Priyanshu, Shubham, nahi, Priyanshu, Shubham, nahi, no. Deepti Singh.
Yes, sir.
What is the meaning of V pi S2?
So it will be the expected DCFR given that I have started from S2.
And following pi.
Yes, sir. That is given that we are in a specific policy.
ठीक है. What about this?
So Q value would be that given a specific policy and a state action pair, what is the maximum DCFR that can give me?
Yeah, so what is the maximum DCFR I can achieve if at state S2 I have taken A1 action and after that I started to follow pi. लिख लो इसको. ये 100 बार आएगा. It is going to be there for 100 times. It has to be exactly in the same way fixed in your mind. What does it mean? At S2 state, if I have taken action A1, after that I keep on following the pi. what is the maximum DCFR, expected value of the DCFR that I'm going to get. Okay. Similarly, because there are two actions, A1 and A2, you are also going to get Q pi S2 A2, and you will be getting pi S2. So pi A1 given S2, pi A2 given S2. Are they the real ones or the best one? No, then there can be a best one. We don't know this best one, but this also exists theoretically. So we may have a random policy to start with, and later we got the optimal. So this exists. We wanted to get it using some solution, but this means that given this policy or the best possible policy, so if you give me, if I'm at S2, if I take this action, what I'm going to get? If I'm take this action, what I'm going to get? Can anyone tell me that given all these things, if you are at state S2, which action you are going to take? Which action you are going to take? No. Prashant, can you tell? A2. A. How can you say A2, Komal?
सर जिसकी प्रोबेबिलिटी ज्यादा होगी
हाँ.
पाई स्टार जो है
Fourth one से पूछोगे ना?
यस सर
Yes, yes, that is the answer. We are going to use the fourth one to tell me that इसको चुना जाए कि इसको चुना जाए. Okay. Q pi S comma A. How good it is to take an action A at state S and then follow pi. Okay. Basically, the expected DCFR if at state SA action has to be chosen. Okay, let me write it down. That is the neat and clean way to write it. That given ST is equal to S, AT is equal to A, given pi, because after that I'm going to follow the pi, what is the expected DCFR that I am going to get? Okay. This can be equivalently right, and you again please see this T plus K and K. Maybe answering the Komal's question again. T plus K and K equal to 0 to infinity is equivalent to write T starting from 0. Now K is not there. It will be RT and gamma T. And I have shown that diagram again, that suppose that this is your global time, which obviously start from some T equal to 0. And if you are following that, then at some point T equal to T dash, you may be over here. And now you start your counter K. What is the DCFR for this? So your future rewards are 1, 2, 3, 4, 5, 6, and keep on adding. So it will be T dash, then T dash plus 1 plus T dash plus 2. So that is basically T dash plus K, and K equal to 0 to something that was being written previously. Now it is saying that, hey, let us write it in much more simple or elegant way. Now I am saying that T equal to 0. Everything is starting from T equal to 0. Then it will be RT and gamma power T. I assume that this is trivially okay and simple to everyone. Both of them are equivalent. So previously it was RT gamma RT plus 1, gamma square RT plus 2, and so on. Now it will be R0. Why R0? Because even if you are at S5 or S8 or S25, don't care, because right now we are saying that is S0 for you. That's your starting state. There's the starting reward, then the second reward, the third reward, the fourth, the fifth, the sixth, and keep on adding with discount factor. So now you understand that Q function, okay? You understand value function, okay? You understand pi, okay? You understand pi asterisk, okay? Now, what is V asterisk? V asterisk is this. Maximize over all pi's. What is the best that you can get for a state? You are at a state. You are saying, hey, this state is very bad. Why? Right now, Ukraine is in a very bad condition. But that is with respect to their current policy pi. It is not the case that every time Ukraine will be in a bad position, bad value function. You tell me pi, with respect to this pi, this state is bad. Then I change pi. Then I change it again. Then I change it again. It is saying that whatever be the policy, out of all policies, you choose the one for which the value function of this state is maximizing, that is your VSTS. In that case, there may be some S for which, no matter what is the policy, it is always bad. Maybe such an example can be, it's very difficult to get a state which is for all the pi's, it's always going to be very poor. Very, very poor, in fact. But so suppose that as a state is a prison. You don't want to go to prison. There is not no policy under which going into prison is going to be helpful. But still, you may define that during freedom fight and so on, going into a prison may be a good state or so. But forget about that. I'm just giving you the analogy that take a state out of all pi's, whichever one is going to give the maximum value. That is what is going to be V asterisk S. What is Q asterisk S? Same thing. For this state, if you take this action, after that you follow pi and do it for all the pi's. Whenever you get the maximum, that is your Q asterisk S comma A, which can also be written as like this. Maximizing over all pi's expected DCFR when your initial state is S and in action that you have taken is A. Now, please draw this.
Excuse me, sir.
Puchiye.
Sir, would it be right to say that for different state S, I can have different policies giving V asterisk of that S?
No, it is not the thing. What I have said is simply the definition. This definition says that if you know, that doubt may also arise that for this state my policy may be different, for other state my policy may be different, for other state the policy may be different. But understand, when there is an optimal policy, all the possible sub path, sub problems, they also have the optimal structure. So I'll come back to it. Maybe it may take some time, but right now you understand that's the definition of Q asterisk S comma A. Q asterisk S comma A says that at state S, if I take an action A, at max, I am going to get Q asterisk S comma A. Nobody is in the earth going to give me anything more than Q asterisk S comma A. That is the physical definition. Deepti, sorry. Right?
Yes, sir.
Okay. We'll talk about this because that's an interesting thing. Maybe I'll come back to it. Now you please draw this diagram again. Agent state is S. Keep on drawing with me. Jaldi jaldi. Agent state is S. It has taken an action A, so that it has gone to state S dash, got a reward R. Now, so there are k possible actions. So at S1, sorry, S dash, it is taking A1. It may take A2. It may take A3, A4, A5, A6, A dash, and finally AK. And it will reach to different states, right? Because if you take these actions, who is going to tell you that what is going to be your next state? Or Balkar, tum ab aaye ho. Balkar, are you crediting or auditing?
So crediting, sir.
क्रेडिटिंग कैसे समझोगे? तुम्हारा तो गेम हो जाएगा.
सर थोड़ा लेट हो गया.
लेट होना नहीं चाहिए भैया, अभी तुम्हें समझना बहुत मुश्किल पड़ेगा, इसलिए लेक्चर को रिकॉर्डिंग सुन लेना. चलो, एस डैश स्टेट पे आप A1, A2, A3, AK कोई भी ले सकते हैं. इफ यू टेक, देन यू विल बी एंडिंग अप विद सम डिफरेंट स्टेट्स depending upon your action. By the way, who is going to tell you that what is your next state? Next state क्या है? उत्कर्ष कौशिक बताइए. उत्कर्ष कौशिक.
एनवायरमेंट.
एनवायरमेंट बेसिकली हमारा कौन बताएगा? ये प्रोबेबिलिटी फंक्शन P. ठीक है, ट्रांजिशन प्रोबेबिलिटी. ठीक है, और ये MDP पे है. मैं बार बार इसलिए बताता हूं क्योंकि किसी के भी दिमाग में ये ना आए कि हम वो सब चीजें लर्न कर रहे हैं. बार बार आदमी को मैं इसलिए बताता रहूंगा, वो सब है तुम्हारे पास. इट्स नोन, गिवन, एम्बेडेड इनसाइड माई गेमिंग लॉजिक. ओके, तो एजेंट एस स्टेट से एस डैश स्टेट पे गया. ए एक्शन करने पे रिवॉर्ड पाया R. उसके बाद इट कैन टेक A1 में रीच ओवर हियर, A2 में रीच ओवर हियर, A3 में रीच ओवर हियर, एंड सो ऑन एंड सो ऑन एंड सो ऑन. नाउ यहां से वो कितना ले सकता है? So what is the meaning of this? कौन बताएगा? What is the meaning of this term?
For a given state S dash, if it takes an action A1, then what will be the expected value of reward? Means DCFR.
इससे ज्यादा कभी नहीं आ सकता. करेक्ट?
Yes.
तो ये बेस्ट है जो यहां मिलेगा.
हाँ, best for each policy means every policy in the
Best out of all the policy, not every, out of all policies. इससे ज्यादा कभी नहीं पा सकते. अरे भाई, तुमने क्रिकेट टीम बनाई, क्रिकेट टीम में अगर तुमने तेंदुलकर को ले लिया, चाहे उसके अलावा किसी को, बट सबको ले लो, इससे ज्यादा रन नहीं बना पाओगे. ठीक है, ये मैक्सिमम है. अच्छी बात. तो एस डैश पे A1 लेने के बाद मान लिया कि बेस्ट हुआ तुम्हारे साथ, तो तुम इतना पाओगे. उसके बाद टर्मिनेट हो जाएगा तुम्हारा एपिसोड. ठीक है
सर, ये क्यू स्टार जो है ये पर्टिकुलर पॉलिसी के लिए है ना? पाई मतलब जरूरी नहीं पाई स्टार का हो ये.
अभी कोई पॉलिसी के बदले तुम ये मानो कि इसके बाद तुम्हें भगवान मिल गए इस एक्शन को लेने के बाद, तो तुम इतना
तो पाई स्टार, तो ये पाई स्टार पॉलिसी की क्यू स्टार है, मतलब पाई स्टार को फॉलो करते हुए.
हाँ, पाई स्टार नहीं. अरे बहुत ही अंदरूनी आपने बात बोली है. ठीक है, यही बात वो लड़की भी पूछ रही थी, दीप्ति, उसको मैंने वहां रोक दिया था. अच्छा राई, तुमने क्वेश्चन पूछा, इससे क्या होगा ना, आप समझ पा रहे हैं. बट इट इज नॉट द केस सेवरल टाइम्स. कई बार क्या होता है कि, so I will come back to it because it takes, DP thing. but first understand, and
Okay,
it's good that you have got this thing in your mind कि whether, तो इसके बाद मैंने पाई स्टार को फॉलो किया, तो इसके पहले मैंने पाई स्टार को तो फॉलो किया नहीं, तो इसका क्या ये पूरा पाई स्टार में आ ही नहीं सकता फिर, तो ऐसे बहुत से क्वेश्चन उठेंगे. सो वेट फॉर दिस. राइट नाउ मैंने बहुत ही प्लेन एंड सिंपल बात लिखी हुई है. आपने एक डिराइव्ड क्वेश्चन पूछा विच इज अ गुड क्वेश्चन, ठीक है, बट अभी मैंने एक प्लेन और सिंपल बात लिखी बिकॉज विच इज जनरल, विच इज ट्रू, दैट मे और मे नॉट बी ट्रू. सो राइट नाउ व्हाट आई हैव सेड आफ्टर दैट, अगर तुमको भगवान भी मिल जाए तो इससे द रिवॉर्ड नहीं दे सकते, तो दैट इज द बेस्ट दैट यू कैन हैव. इफ यू टेक 80 A2, then this is the best, or this is the best, or this is the best. Clear सबके दिमाग में. अभी एक रेड सी लाइन बनी है, मैं कहता हूं ये था, मान लो कि ये सबसे अच्छा था. क्या मतलब हुआ? इसमें 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 सबसे अच्छा इसका था, assuming A' का सबसे अच्छा रिटर्न आता है. ओके, then Q asterisk S comma A. अभी किसकी बात हो रही थी, प्लीज देख लीजिए. अभी आप इस स्टेट से बात कर रहे थे, इस स्टेट के लिए Q asterisk की बात कर रहे थे. What we wanted to show that this is a recursive definition, because in order to know Q asterisk S comma A, you need Q asterisk S dash comma out of all the best one. कैसे? S comma A asterisk के केस में, which is the best that you can have, R. Why? Because R you have got, and then you have reached to S dash plus gamma times. Why? Because the discounted thing, max of maximum that you can get via A1, via A2, A3, A4, so on. So इन सब में जो सबसे अच्छा है कौन था वो? मान लो वो A' था. You can ask or write. Please keep on writing. At least you write, then you can understand what I am saying. Why I am
ऐसा
taking...
मतलब इसमें यही डाउट था कि मतलब जो हम ईच स्टेट पे हम क्यू स्टार निकालने का ट्राई कर रहे हैं, वो मतलब पर्टिकुलर पॉलिसी को फॉलो करते हैं.
नहीं, अभी हम ट्राई नहीं कर रहे हैं. अभी हम लोग ट्राई नहीं कर रहे हैं, अभी हम डिफाइन कर रहे हैं सिर्फ. ये डेफिनेशन है.
नहीं मतलब सर हम एक पर्टिकुलर पॉलिसी फॉलो कर रहे हैं ना.
अभी हमने पॉलिसी, हमने बोला कि अगर आपके पास ये क्यू एस्टिक हो, या आपसे मैं बोलूं कि भाई क्यू एस्टिक एस कॉमा ए बता दो, आप कहते हो कैसे बता दो, तो मैंने कहा ऐसे बता दो, क्योंकि क्यू एस्टिक एस कॉमा ए एक रिकर्सिव इक्वेशन है. इसी रिकर्शन को सॉल्व करेंगे. Once we solve this recursion, there is going to be a termination condition and there is a initiation condition. उनको इस्तेमाल करते हुए ये चीजें निकलेंगी. बट फर्स्ट वी नीड टू अंडरस्टैंड कि क्यू एस्टिक का मीनिंग क्या था, मैंने बता दिया. अगर वो क्यू एस्टिक का मीनिंग था तो क्यू एस्टिक एस कॉमा ए डिकम्पोज हो जाता है क्यू एस्टिक ऑफ दिस पे. जैसे याद करो, फैक्टोरियल 5 मैंने पूछा तुमसे, बताओ फैक्टोरियल 5, मैंने कहा नहीं पता तुमको, तो तुमने कहा सर बता दूंगा. फैक्टोरियल 4 बता दो, तो मैंने कहा दूसरे लड़के से तुम इधर आओ, तुम बताओ फैक्टोरियल 4. वो कह रहा नहीं पता, बता दूंगा अगर आप फैक्टोरियल 3 बता दो. क्या हो रहा है? हम लोग रिकर्शन बना रहे हैं. दैट इज द थिंग, वंस वी अंडरस्टैंड वी कैन सॉल्व दैट रिकर्शन कि फैक्टोरियल 1 तो सर 1 होता है, फिर उल्टा आने लगे स्टैक में. आई बात समझ में?
यस सर.
ओके, सो द पॉइंट इज कि इस स्टेट पे इस एक्शन को लेने के लिए क्यू एस्टिक की जब बात करते हो तो तुमने कहा नहीं पता, बता दूंगा. अगर तुम क्यू एस्टिक एस डैश पे बेस्ट एक्शन बता दो, इसके लिए बेस्ट एक्शन क्या है। हमने मान लिया कि इसके लिए बेस्ट एक्शन ये है। आप बोलोगे किसने बताया, मैंने कहा यार मुझे भी नहीं पता, लेकिन मान लो कि कोई ऑरेकल बता दे, तो अगर आपने बता दिया कि A1 है, then it is gamma q asterisk s dash a dash r. Simple. Basically q asterisk s comma a is equal to r plus gamma time maximum of all the actions. Basically this is q asterisk. Now you again write it down. Q asterisk s comma a is equal to the expected value of s dash belonging to epsilon r plus gamma times max out of all the actions. ये क्या हो गया, आपको आवाज आ रही है?
यस सर,
Yes, sir.
हेलो, आपको आवाज आ रही है?
Yes, sir.
यस सर।
अच्छा ओके, चैट पे लिख दो क्योंकि यहाँ पे कंप्यूटर रिस्टार्ट हुआ है। आई कैन सी इन माई चैट, कैन यू राइट दैट यस सर? उत्कर्ष ने बोला है यस सर, ओके। सो हाँ, एक मिनट रुको, ये सेलेक्ट करना पड़ेगा। टीवी रीस्टार्ट हो गया, टीवी हैंग्ड। एक मिनट, which one? Yeah. हाँ, अभी आवाज आ रही है?
Yes, sir.
Yes.
यस
ओके, थैंक यू। इज दिस ओके? क्वेश्चन पूछो इस पे अगर आपको पूछना है। इज दिस थिंग ओके टू यू? नो। इफ यू आस्क देन आई एम गोइंग टू आंसर इट। पूछिए, कोई क्वेश्चन नहीं है?
सर गामा की वैल्यू चेंज कर सकते हैं ना, मींस एवरी केस के लिए।
हाँ भैया, चेंज कर लेना गामा की वैल्यू, उसमें क्या बड़ी बात है। इसमें क्वेश्चन पूछो, इसमें कोई क्वेश्चन है? लेट्स गो टू द लास्ट स्लाइड। ये देखना है कि ये देखना है? हाँ कोमल कुमार, अब बोलो। स्टेट एक्शन नेक्स्ट, और पीछे, इससे पीछे जाए कि क्या होगा? ये तो तुम लोग के माइक वाइक चलते नहीं है, पता है मुझे, इतनी दूर से दिखता भी नहीं है।
सेकंड लास्ट,
ये क्वेश्चन ही निकल जाएगा, क्या क्वेश्चन पूछना था भाई? ये सब तो बता दिया मैंने आपको। मेरा क्वेश्चन है, इसमें क्या क्वेश्चन है? डू यू वांट टू आस्क एनीथिंग? पूछोगे नहीं तो मैं नहीं बताऊंगा। दीपाली पूछ रही है, पूछो।
नो सर, नहीं है।
तो इसमें क्वेश्चन तो बताओगे, क्या है क्वेश्चन?
sir, what is the difference between last two queues, S tag and this?
तुम इतना उसको कहते डिस्क्रीट बोलते हो। एक फ्लो में बोलो, मेरे समझ नहीं आता है। फिर से पूछो कोमल। अब बता नहीं रहे हो, पूछो।
So, actually, he was asking, and I have this question too, that आपने पीछे जो इक्वेशन दी थी q asterisk s इक्वल r प्लस गामा इंटू q asterisk s डैश a डैश, तो उसमें और इसमें डिफरेंस क्यों है? मतलब इसमें एक्सपेक्टेशन ओवर ऑल स्टेट्स क्यों है?
हाँ, यही तो क्वेश्चन है, ये वाला क्वेश्चन है ना, यही क्वेश्चन है ना आपका?
यस सर।
हाँ, वही तो मैं कह रहा था कि कोई क्वेश्चन पूछे तो मैं बताऊं। ये तुम जो है ना कोमल, तुम यार अपना ये माइक वाइक लगा के आया करो। ये चैट दिखता नहीं है भाई इतनी दूर से, पता है इतना छोटा सा वहां टीवी पे लिखा हुआ है, तो पहले मैं आगे पीछे ही करता रहता हूँ, उतनी देर मैं भूल जाता हूँ। माइक क्यों नहीं चलता है तुम्हारा? माइक चलना चाहिए ना। एक तो मोबाइल पे पढ़ रहे हो, तुम्हें मोबाइल पे मना किया था ना पढ़ने को। आर यू यूजिंग योर मोबाइल मिस्टर कोमल कुमार? राइट डाउन। लाइब्रेरी, son, I'm in library. Which library you are? You are in institute. South. मेरे पास आना चाहिए ना तुम्हें, तुम्हें यहां मेरे सामने आके बैठना चाहिए। कल से कोमल कुमार तुम आओगे और यहां बैठोगे, यहां सामने, यहां सामने तुम्हारे लिए कुर्सी डाल देंगे। Those who are in the campus, please raise your hand. अगर आप कैंपस में हैं, ये चैटिंग वैटिंग वो क्या कहते हैं बंद करो, इस पे आना, सामने आओ, हाइब्रिड मोड चला देंगे, ठीक है? यस, सो यू कैन कम ओवर हियर। 3-4 guys are here. बलकार इज आल्सो हियर। बलकार, एक तो तुम इंस्टीट्यूट में हो, ऊपर से लेट आ रहे हो, तुम लोग कमाल करते हो। लेट वेट नहीं आओ भैया, ये सब गड़बड़ हो जाएगा। और कोमल कुमार तुम मेरे को क्लास के बाद फोन करना, क्लास के बाद टेलीफोन करना तुम मुझे।
सर कौन सी क्लास में आना है?
हाँ ये अच्छा क्वेश्चन है, तो ये मैं बता दूंगा तुम्हें। ये हॉल एबीसी के ऊपर बैठते हैं हम लोग, ऑडिटोरियम है, ऑडिटोरियम में हॉल एबीसी है, उसके ऊपर, ठीक है?
ठीक है।
और ये लाइब्रेरी में मत बैठ के पढ़ा करो, मतलब जब क्लास चल रही है। अब जवाब ही नहीं दे सकते तो कहाँ से क्लास होगी? इतना सारा लिख दे रहे हो वहां पे। ये चैट वैट मेरे को नहीं पसंद आता, ना मोबाइल के ऊपर ना ये व्हाट्सएप, ठीक है? तो ये क्वेश्चन का जवाब देते हैं। मैंने अटका के इसलिए रखे रहा कि तुम्हारे दिमाग में बने तो क्वेश्चन मैं ही बता दूं क्या। तो देखते हैं। S1 स्टेट पे ए एक्शन लेने पे, या सॉरी S स्टेट पे ए एक्शन लेने पे मैं S1 पे भी जा सकता हूं, S2 पे भी जा सकता हूं, S3 पे भी जा सकता हूं। भूल गए ये वाली बात? मैं S1 पे गया 0.3 प्रोबेबिलिटी से, S2 पे गया 0.4 प्रोबेबिलिटी से, S3 पे गया 0.3 प्रोबेबिलिटी से, और इसीलिए मैंने S डैश बिलोंगिंग टू एप्सिलॉन रखा। एप्सिलॉन इज अ सेट ऑफ स्टेट्स जिन पे मैं पहुंच सकता हूं, क्योंकि मेरा गेम डिटर्मिनिस्टिक भी हो सकता है, नॉन डिटर्मिनिस्टिक भी हो सकता है। दीपाली, सॉरी दीप्ति, ठीक है? ये बात नहीं आई समझ में कि आ गई?
यस सर,
आ गई। हाँ, तो ये एक्सपेक्टेशन इसलिए लगा है यहाँ पे, इसीलिए मैं बार बार बोला था कि ये पूछो मुझसे ऐसा कुछ, ठीक है? अच्छी बात। अदरवाइज सब कुछ सेम है, अदरवाइज सब कुछ सेम है। तो तुमको भी पता है कि 0.3 प्रोबेबिलिटी से S1 पे जाएंगे तो S1 के करस्पॉन्डिंग से, तो जब यहां पर तुम S1 रखते हो तो जो कुछ भी है उसमें 0.3 डालना, S2 रखते हो उसको 0.4 डालना, 0.3 डालना, और मल्टीप्लाई करके तीनों को जोड़ करके वैल्यू यहां लिख देना। करेक्ट, समझ गए? नाउ इंपॉर्टेंट चीज, तो आप लोग पूछ रहे थे क्या कर रहे हैं, ये क्यू एस्टिक क्यों बताया? देखो क्यू एस्टिक, अंडरस्टैंड, क्यू एस्टिक नहीं, क्यू नहीं, क्यू एस्टिक। ये थोड़ा आगे का क्वेश्चन है, आपके दिमाग में अभी नहीं उठेगा, बाद में उठेगा, लेकिन मैं पहले ही बता दे रहा हूं आपको समझने के लिए कि क्यू एस्टिक और वी एस्टिक दोनों के दोनों बेलमैन ऑप्टिमैलिटी या बेलमैन इक्वेशन को फॉलो करते हैं, एंड दे आर डिफाइंड रिकर्सिवली, बिकॉज ये दोनों ऑप्टिमल है। कोई भी चीज ऑप्टिमल होगी और रिकर्सिवली डिफाइंड है, वो बेलमैन ऑप्टिमैलिटी को फॉलो करेगी। अगर आप ऑप्टिमल हैं, मान लीजिए एग्जाम्पल के तौर पे ये है इंडिया, सॉरी इंडिया नहीं, IIT मंडी, और ये पहुंच गया USA MIT, और ये इसका ऑप्टिमल पाथ है। यदि इफ दिस इज माय ऑप्टिमल पाथ, then everything which is in between it's optimal. ये पूरा ऑप्टिमल है. अच्छा, तो क्या ये ऑप्टिमल होगा? आपको क्या लगता है? दीपाली आप बोलिए.
Yes, sir.
अगर ये ऑप्टिमल है तो क्या ये ऑप्टिमल होगा?
Yes, sir. Because हम टारगेट पे पहुंचने जा रहे हैं, तो होना चाहिए.
तो क्या ये ऑप्टिमल होगा?
Yes, sir.
तो क्या ये ऑप्टिमल होगा?
Yes, sir.
कैसे प्रूव कर सकते हैं कि ऑप्टिमल होगा?
Hmm.
कोई बता सकता है?
सर हम रिवॉर्ड मैक्सिमाइज कर रहे हैं तो ईच स्टेप पे हमको रिवॉर्ड मैक्सिमाइज करना पड़ेगा ना.
ये आंसर नहीं है वैसे, बट उससे पहले ये ऑप्टिमल है. This thing is optimal. My question is that whether this is optimal or not.
Sir, it is.
Why? How can you prove?
सर अगर वो ऑप्टिमल नहीं होगा तो जो वहां के लिए ऑप्टिमल होगा वो वाला पाथ यूज करके उससे भी एक ऑप्टिमल सॉल्यूशन बना सकते हैं.
गुड, समझ गए बात. अगर ये ऑप्टिमल नहीं है तो कुछ और ऑप्टिमल था, वो ऑप्टिमल यहां रख दो. अगर वो ऑप्टिमल यहां रख दिया तो ये ऑप्टिमल नहीं था. दैट इज प्रूफ बाय कॉन्ट्रडिक्शन. कर लेंगे सभी कोई? एनीवेज ये बहुत सिंपल सा शॉर्टेस्ट पाथ एल्गोरिथम में आता है बेलमैन इक्वेशन और बेलमैन सॉल्यूशन. बेलमैन एल्गोरिथम सबको आती है? हाथ खड़ा करो जिसको नहीं, जिसको आती है. बेलमैन, डाइक्स्ट्रा एंड बेलमैन एल्गोरिथम. टेल मी, हाथ खड़ा करिए. डाइक्स्ट्रा एल्गोरिथम, बेलमैन एल्गोरिथम. 2 लोगों ने बोला है सिर्फ. सुजीत को आती है. गुड. दीपाली को आती है. डाइक्स्ट्रा एंड बेलमैन, डाइक्स्ट्रा एंड बेलमैन, डाइक्स्ट्रा एंड बेलमैन, डाइक्स्ट्रा एंड बेलमैन. आपको याद होगा कि डाइक्स्ट्रा और बेलमैन में एक ही फर्क है. डाइक्स्ट्रा और बेलमैन में कोई एल्गोरिथम ग्रीडी है और दूसरी क्या है? डीपी है. सो चूंकि एक एल्गोरिथम ग्रीडी है, एक एल्गोरिथम डीपी है, बेलमैन डीपी है और बेलमैन के अंदर निगेटिव वेट्स और ये सब आते हैं. ये मैं क्यों कह रहा हूं? अगली क्लास में आप इसको पढ़ के आएंगे. इसके नोट्स इसमें दिए भी हुए हैं, ये आपको शेयर हो जाएगा. बेलमैन शॉर्टेस्ट पाथ एल्गोरिथम आप पढ़ के आएंगे अगले लेक्चर में. सो ये फिर से वही बात लिख दी, आप लोग समझ गए होंगे. S से A लेने पे मैं S1, S2, S3 कहीं भी जा सकता हूं. S1 का बेस्ट ये है, S2 का बेस्ट ये है, S3 का बेस्ट ये है. इन तीनों का एक्सपेक्टेड, तो इन सब की एक्सपेक्टेड यहां से एक आएगा, एक दूसरा आएगा, एक तीसरा आएगा. उन सब का एवरेज लिया जाएगा एक्सपेक्टेड वैल्यू के आधार पे. यहां से जो मैक्सिमम आएगा उसमें 0.3 लगेगा मल्टीप्लाई, 0.4 लगेगा, 0.3 लगेगा और जोड़ करके इस बंदे के लिए बनेगा. Now, again writing the optimal policy. Again writing the optimal policy. पता नहीं क्यों. आवाज आ रही है ना?
Yes, sir.
Okay. MDP policies depend on current states. नॉट ऑन द हिस्ट्री. कोई फर्क नहीं पड़ता आपने पिछले मैच में कितने रन बनाए थे. आज के मैच और आगे होने वाले मैचेस में आप कितने रन बनाएंगे. Hence policies are stationary time independent. Pi S given A is probability STS पे A लेने की क्या प्रोबेबिलिटी है. This is the stochastic policy. Stochastic policy समझते हैं ना. मैंने अच्छा मैं एक बात आपको बताना गया भूल कि it can be, let me draw, कि मैंने आपको पॉलिसी दी. पॉलिसी ने बोला A1, A2, A3, A4. A1 लोगे 0.2 प्रोबेबिलिटी से, 0.6 प्रोबेबिलिटी से, 0.1 प्रोबेबिलिटी से और 0.1 प्रोबेबिलिटी से। अब बताओ बलकार आप ये बताओ कि आप क्या एक्शन चुनोगे, क्या एक्शन चुनोगे?
सर A2 उसमें लाइक मैक्सिमम प्रोबेबिलिटी है उसकी।
A2 चुनोगे, करेक्ट, लेकिन डिटर्मिनिस्टिक होता। स्टोकेस्टिक पॉलिसी क्या होती है? एक्सप्लोरेशन अलाउ करती है। तो आप हर बार यही नहीं चुनोगे, आप एक्सप्लोर करने के लिए इवन दो यू नो यार यही करना है, यही सबसे सही है। जैसे आप गए मैकडोनल्ड्स, मैकडोनल्ड्स में आपके पास बहुत सारा नया नया चीज लगा हुआ है, लेकिन आपको सबसे ज्यादा पसंद क्या है? कोई भी एक बर्गर आपको सबसे ज्यादा पसंद है, आपने बोला मुझे ये बर्गर तुरंत दे दिया जाए। 0.6 प्रोबेबिलिटी से आप बर्गर बोला जा रहा है आप लेंगे, क्योंकि आप ही कह रहे हैं, आपकी पॉलिसी है। लेकिन कभी कभी आप फिर भी बर्गर नहीं लेते क्योंकि आप एक्सप्लोर करना चाहते हैं। दैट इज कॉल्ड एक्सप्लोरेशन कैन बी अलाउड within this stochastic, which means that when I am going to take an action with 0.9 probability, maybe 0.8 probability, maybe a high probability, I'll choose the one which is the best. With a small probability, I choose some random thing which will allow me for exploration. This is called an interesting strategy. This is called as epsilon exploration, epsilon exploration, which means that with a small probability I will be exploring, and with a high probability I'll be choosing the correct decision. ठीक है? Okay, this is what swing shown over here. ये सारी बातें हम लोग कर चुके हैं। Now, how to solve for optimal policy? Because it's a dynamic programming. Now, why is a dynamic programming? You have states, you have actions. For every state, you can have all possible actions. Your actions are right now discrete. Your states are finite. Understand these words very carefully chosen. Your states are discrete and fixed. Sorry, your states are discrete, yes, and they are fixed. That's true. Your actions are also discrete and they are fixed. So for every state you have some actions. For every state action pair, you can have Q values, you can have values. For state and action, you will be having a Q value. For states, you will be having the values. Both of these things are actually somehow try to follow Bellman optimality. So there is a DP solution. How? Let us see one by one. So first we need to figure out how to evaluate a policy. Because the point is that if I give you a policy, how can you say whether this policy is good or a bad policy? Because you need to understand that given something, I need to know how can I evaluate so that I can improve. Abhi aap class mein I don't know how to evaluate. I keep on asking questions. With that, I understand what you all are trying to understand the whole phenomena. And then I give you different things so that you started to get better and better and better. So first, how can I make you better? I need to understand how can I evaluate a student? How can I evaluate a policy? So we want policy evaluation. Okay. Later, once we know how to evaluate a policy, later Bellman equation, policy iteration, maybe over the value, maybe over the Q function, we keep on updating using the Bellman optimality equation. By the way, everything is in the way we used to solve it in a DP. So basically, we are assuming policy. And if I assume a policy, it is basically going to give me a value function at ith step. And I am assuming that it is optimal. Remember, your V function for a given pi, is it optimal? We don't know. Because we know that V pi asterisk is optimal, but pi asterisk I don't know. Pi is some random function. I am assuming that right now at ith step, whatever you have as your policy, is it that's an optimal function. And use it to compute the policy or the value function for I plus 1th step. Oh, so what does that mean? I may be having, okay, let me show you. Okay, I am done with this, but I am going to tell you this whole thing again in a very simple way. Okay, so I will be having maybe a pi, some random pi. I evaluate, slightly modify it. I got maybe pi 2. Slightly modify it, pi 3. Slightly modify it, pi 4. But the cycle is that I am assuming, okay, so how I am updating? I am updating using Bellman optimality. But how can I apply Bellman optimality? Because this pi itself is not following it's not the pi asterisk. So it's not following Bellman optimality. So my assumption is that my policy at ith step is good, best, and utilizing that from pi, I just calculate the value function. From value function, I can again come back to pi. From pi, I can go to value function. From value function, I can come to pi. But this time, this pi will be different than the actual pi, the previous pi. Maybe can I use a place where things are, I can have more space. Okay, let me go to, can I add some page over here? No, wait, मैंने बंद कर दिया. Okay, कोई बात नहीं, खोल देता हूँ. This is the blackboard. Yes, so what I'm trying to say over here is that I'm having a pi, maybe pi 0. If I give you pi, you can compute the value function because that's very simple for you. So from pi 0, we can get the value function. With this value function, I can again go back to my pi using Bellman optimalities. You will get pi 1. I can get another V. Again go back. Then again pi 3. And again go back. And keep on doing. So I am utilizing the Bellman optimality. What is this Bellman optimality? I'm superimposing. It is just like that. Because it is Bellman optimality, if you assume that you have got the best, this is my assumption. If I have got the best, and since Valkar is connected to me, I assume that it also have to be getting the best. how far it is from the best. That is the thing that we need to somehow understand, that if I am the one who is getting the maximum, I am the optimal one, then things which are coming from me, connected to me, the same way, the whole thing that I have shown, that if this whole thing is optimal, then every subpath is optimal. This is the assumption. Wherever it is failing, Bellman optimality is need to be somehow ensured. That we will be maybe going to see in our next lecture. May not be very clear right now that what is going to happen. That is good for you to, you know, speculate that what is going to happen. But what you need to do is that please go to this lecture. It's anyways available. DP review. I am not going to cover this. This is the DP review. You need to understand this algorithm, Bellman-Ford shortest path algorithm. And it is being shown, all these things, how this recurrence is actually being drawn. And once you understand this whole recurrence, which is opt of I comma v is equal to the mean of this, and so on. With this, I am going to be starting with this whole thing. So this is the environment, this is the agent, action, policy, reward. We will be initializing from here so as to let you understand. So we will be seeing how we can evaluate a policy, how we can iterate our policy. And once you started to keep on iterating over a policy, you can make it better and better and better and better. But that's a DP solution. You need to understand DP review, which is called as the Bellman optimality. ठीक है कोमल? कोमल कुमार, आप लाइब्रेरी में हैं. Okay, good. Others, fine?
Yes, sir.
ठीक है. दीपाली, दीप्ति, प्रियांशु, प्रशांत, कोमल, बलकार, उत्कर्ष, गीतांजलि and Suji. Thank you. So we are done with this. Next lecture, we will be starting from. Okay.
Sir,
बोलिए. हाँ.
sir, if a policy in any given policy, if we take an action at state S, then we don't know which state will be going after that action. So for each policy or for each action, the state will change or not. Different state for different policy for a given action.
At a state, if you take an action, that you are going to get a state.
For each policy, every policy it will be different or same.
नहीं. स्टेट पे अगर एक्शन बता दिया तो इन्वायरमेंट ही बताएगा ना कि क्या होगी नेक्स्ट स्टेट.
Okay, means environment dependent होगी policy, but
of course environment dependent होगी ना. इस स्टेट पे तुम पॉलिसी एक्शन लेना सिखाती है बस.
वो स्टेट नहीं बताएगी, वो बस एक्शंस बताएगी.
हाँ, वो स्टेट उसको स्टेट बताओ तो वो ये बता सकती है कि इस एक्शन कौन सा एक्शन है वो बेस्ट है, अगर सबसे अच्छी आपको वो पाई, अगर आपका अच्छा है तो.
ओके सर, ओके.
यही मैंने कहा. एक्चुअली क्या है, आई नो ये बहुत बार कंफ्यूज करेगा, क्योंकि आप जिसकी बात कर रहे हैं दैट इज पी, दैट इज अ ट्रांजिशन प्रोबेबिलिटी, दैट इज नोन. स्टेट पे एक्शन चुनने से कहां जाऊंगा ये डिसाइडेड है. ये पी के तहत है.
ये एनवायरनमेंट डिसाइड करता है.
या एनवायरनमेंट डिसाइड करता है. करेक्ट.
ओके सर, थैंक यू सर.
ठीक है. ओके, थैंक यू.
हेलो सर.
हाँ प्रियांशु बोलो.
सर अभी भी ओएस पे ये फ्री स्लॉट नहीं हुआ है इसका, तो अभी भी मैं रजिस्टर नहीं कर पा रहा हूँ इसको.
कौन है जो रजिस्टर नहीं कर पा रहा? वो मुझे
मेल्ड.
दीपाली और प्रियांशु, एक काम करो, मुझे ये मेल आपकी दीपाली क्या रखी, प्रियांशु यू आल्सो मेल मी, मैं इंडिविजुअली कर दूंगा. मेरे को एक ठीक है.
सर मैंने वैसे ओएस को मेल कर दिया है कि फ्री स्लॉट कर दो, तो शायद
अलग. हाँ सुनो मेरी बात, मैं आप तुम लोग को बता रहा हूँ. ओएस कुछ अलग कहानी बता रहा है. मैं इसको क्या करूंगा कि आज जो लोग मुझे जिनका नहीं आया, दीपाली का मेरे पास मेल आ रखा है, प्रियांशु एंड प्रशांत आप लोग भी कर दे मुझे ही, सिर्फ मुझे. मैं यहाँ से बोलता हूँ कि इनको इंटरनली कर दे, अदरवाइज दे विल टेल मी कि क्या प्रोसीजर है. लास्ट डेट एड ड्रॉप की क्या है बता सकते हो?
3rd March.
थर्ड, ठीक है, आज ही मुझे मेल कर देना प्रशांत एंड प्रियांशु।
ओके सर।
ठीक है, ओके, ठीक है, बाय, थैंक यू।